Lesson 4. We are looking at transformations of functions today. Specifically, we're looking at vertical stretches and compressions. We want to understand how the a value represents a reflection of the x-axis. And we want to be able to graph such functions and be able to state their domain and range. So what I filled out for you right here is just this little chart. This is a recap from quadratic equations, okay? Again, this is our vertex form here. You'll recall that the A contains in it whether we have a reflection or not, as well as a vertical stretch or compression. The H is the shift left or right. The K is the shift up or down. And that we covered in the last lesson, okay, the vertical and horizontal shifts. Today we're looking at what the a value does, not just to the quadratic, but to the other basic functions which were introduced in lesson 2. Okay, so there's your table filled out. Let's take a look at something that we're familiar with. Okay, so we're looking at this function here. Reading the transformations from left to right, let's begin with what the negative does. Well, if you recall from last year, the negative in front of the a value will reflect the function, the quadratic. So let's write that in here. So we have a reflection in the x-axis. Reflection in x-axis. Secondly, we're looking at the 1/2 here. Okay, that 1/2, well, that's our a value based on what we read above. If a is between 0 and 1, ignore the sign, the parabola is vertically compressed. So here we have a vertical compression by factor of Now, here's where we can get some ambiguity, okay? Some teachers will say by a factor of 1/2, which is the a value you see there, or you might see a factor of 2. Okay, some textbooks have that. I'm comfortable with either one. However, the only thing I'm looking for in answers is making sure that you state it's a vertical compression. Okay, that there's no leeway on, but whether you say a 1/2 or 2, in other words, the reciprocal of 1/2, either one is fine. The last two things we have going on here, well, this is from previous lesson. We have a horizontal shift to the right 3 units and a vertical shift down 5 units. So let's write that over here. Horizontal shift. That is right. 3 units. And we have a vertical shift down 5 units. There we go. Okay, to graph this, well, I'm going to go through the process with this quadratic function. And again, like yesterday, I'm going to show how to graph the other functions. We kind of use the quadratic model of graphing and use it for the other functions as well. Okay, so yesterday we started with a basic table of values. Okay, so this is simply the function f of x equals x squared. All I'm doing is squaring the 2 to get me the 4, squaring the 1 to get me the negative, to get me the 1. Okay, squaring the 0 to get me the 0, and so on and so forth. Next, here's the new part. I multiply all the y values by a. So in this case, my a value, okay, and I'm including the sign here, is -1/2. So what does that mean? My y value will be multiplied, so times -1/2, or by 0.5. What does this do to each of my y values? Well, the 4 becomes now -2. The 1 becomes now -1/2. 0, well, that stays the same. 1 becomes -1/2 again, and 4 becomes -2. Step number 3, repeat from yesterday. We add the h to the x's and the k to the y's. So in this case, we are, what are we doing? -3. So I'm going to have a +3 and then a -5. Get to the k values. What does that do? Well, the -2 becomes 1. The -1 becomes 2. The 0 becomes 3. The 1 becomes 4. The 2 becomes 5. Then for the y values, what I'm taking is the last y values from the previous step, and I'm subtracting 5. So this -2 will now become -7. The -1/2 will become -5.5. -5, -5.5, and again -7. Here are our final points which we are going to graph. So looking at them, I'm going to graph 1 and -7, 2, -5.5, 3, -5, 4, -5.5, 5, -7. And let's take a look at what that looks like on my graph. So I'll just undo this, clean it up a little bit, and go over to our grid here. So 1, -7 is going to be right about here. 2, -5.5 is going to be right about here. 3, -5 is going to be right about here. And I think I get the pattern now. It's going to start going down the other way. So I'll make those points a little bit bigger so that they are discernible. There you have it. You got 5 exact points, and I'm going to draw a smooth line as best I can, connecting the points. I can do better than that. Zoom in here a bit. Arrow this way and arrow this way. 1, 2, 3. And there you go. There is our graph of the function. Our domain in this case, well, with all quadratic functions, we will always have all real numbers as our domain. And our range, it's a real number such that, well, you know this is opening down, and it looks like everything is below -5. So we say that y is less than or equal to -5. There you have it. So after this example now, we're going to start to get onto the new functions and look at how the a value affects the functions. And there's no surprises. It's going to stretch or it's going to compress, reflect or not, the original functions. So let's take a look at that in the examples that follow.